Hello, today we're going to look at arc length. Before we do that, we're going to look at something else called arc measure. To find arc measure, that's how many degrees this outside of the circle would be. So that would be 85 degrees. AEB, this it says is a diameter. So this would be 180 degrees. AD is the smallest arc from A to D, so that's 125 degrees. And dB is what's left over from 180, so that would be what, 55 degrees. All right, so those are arc measures. Now, if we have arc length, what we're doing is we're actually measuring with a ruler from here to here. So the measure of from A to C is 1.4 centimeters. Now, the arc measure out here is 100 degrees. Now those are measuring two different things. So if I said the arc measure of AB, that's 100 degrees. If I say the arc length of AC, that's 1.4 centimeters. Now it's nice to have two different measurements, two different ways to look at this, because sometimes we want to know how much of the circle is being taken up by an arc, and other times we want to know how big it is. So this could be 100 degrees, even though this is much larger of a circle than this. So it's good to have two different measurements. Now, when we want to measure and try to find arc length, we could do this top one, but I really don't like it. I like this bottom one. You could do degrees over 360 equals arc length over circumference, or you can just take your degrees over 360 and then multiply it by your circumference. That's going to be your arc length. Either way, it's going to be fine. So if I want to find the arc length of AB here, I can set up a portion 140 over 360 is going to equal x over my circumference. So our radius is 5, so that's 10 pi. Now we multiply it out, and and in pi form, it would be 35 pi over 9, or if we wanted it in decimal form, it would be 12.21. A general process for this, you don't have to do much with this, but to break it down, uh, first you find the circumference, then you write out some proportion or multiply, and then you write the answer in the correct form, depending on what the question asks or what you think. So, so if I wanted to find the arc length of BC here, first I would take 180 minus 70 to get 110, and then set up the proportion. We found the circumference to be 20 pi. You multiply it, and in pi form, it would be 55 pi over 9, but in decimal form, it would be about 19.2. Now, the proportion, I think, starts to make more sense once it's not quite as easy. So here it says the measure of an angle of an arc is 110 degrees, and the arc length is 12. Find the radius of the circle. Well, we know we have angle over 360, or arc angle, is equal to arc length over circumference. So we know once we have this, we can just fill in our missing information. So the measure of the arc is 110 over 360 is equal to our arc length is 12. That's supposed to be a C for circumference. So now we can cross multiply and try to figure out what our circumference would be. So this would be 110 times the circumference is equal to 360 times 12, which is 4,320. And I'm going to divide that by 110. And my circumference is going to be 39.27 repeating. So now, if I know my circumference, I'm still not done because I want to find my radius. So the first thing I do is divide by pi to find my diameter. And I got about 12.5. And if that's my diameter, I just have to cut that in half to get my radius, 6.25. All right, hopefully you can finish the rest of the problems based on that.